In this video, let's focus on JAMB revision questions, and our point of focus is going to be gas laws. We're going to look at how to solve problem on gas law, Charles law, general gas question. I want to use these three formulas and more formulas in solving questions. So if you are preparing for the upcoming JAMB, then you really want to pay close attention to this video, because by the end of this video, you should be able to solve problem regarding this question. And the good thing here is that we also solve multiple problem or questions, and you will see them in the exam. So you only want to beat your pen, your notebook, and your calculator, so you can follow through. There's some questions I will ask to solve in the course of this video lesson. Then you have to drop your answer at the comment section. So now here we have P1, V1 equals what? P2, V2, called Boyle's law. They call Boyle's law equation. P1 means what? The initial pressure. V1 means what? The initial volume. P2 means what? The final pressure. V2 means what? The final volume. And it must be at constant temperature. As we move on, you should be able to understand how you are going to solve questions regarding this question here. Then we have V1, T1 equals to what? V2, T2. It's called Charles law. It's going to be at constant pressure. Now, this video here, I'm not going to explain those various concepts. I only want to show you how to tackle questions, because that is what you are going to see mainly in the exam. Then this one is the combination of Boyle's law and Charles law. This is called general gas equation. So Boyle's law is this one here, Charles law is this, and general gas equation is this one here. So we are going to start solving problem one by one. So let's get into the first question. Now let's look at the first revision question, and this is a typical question you are going to see in the exam. As a matter of fact, they have repeated this question 2 to 3 times previous year, so you really want to pay close attention here. Now the first thing you want to do here, before you can start tackling every question, you must first of all understand that question. And before you understand that question, you must first of all read it and look at the values given to you. So let's look at the question here. If the quantity of oxygen occupying a 2.76 liter container at pressure. Now remember, we have called the first pressure, the initial pressure, the final pressure, the initial volume, the final volume, the initial temperature, the final temperature. So now the first one given to us here. So here we say the quantity of oxygen occupying a 2.76 liter. That is my V1 is what? 2.76 liter. Do you get that? Container at pressure. That's my pressure is what? 0.825 atm atmosphere and 300 Kelvin. So my T1 is what? 300 Kelvin. Like I said, is reduced by half. Is reduced by half. What is the pressure exerted by the remaining gas? Look at something here. What they want to do is to calculate what? T2. Now, what my T2? What do my V2? Now remember, the value was not given to them, but they said that what is the pressure exerted by the remaining gas? Okay, is reduced by half. That is, this guy is being reduced by half here. This guy is being reduced by half. So for you to get what my V2, I will divide this one by 2 to get this one here, because the statement say is reduced by half. Do you get that? So 2.76 divided by what? 2. Half is what? Half is this. It's reduced by what? Half. So I want to divide this one by 2. So if I should do that, 1.38 liter. Yeah, what? 150 what? Kelvin. So I'm going to use the general gas equation, which is P1 V1 equals T1 equals what? P2 V2 what? T2. What I have to do here is what? Make P2 is the formula here. The final what? Pressure. So if I should cross multiply here, I'm going to have P to P what to V to T1, right? Equals to what? P1 V1 T what 2. Do you get that? So what am I going to do here? Divide both sides by what? V2 T1 V2 T1. This is that. Yeah, this will cancel out this. This will cancel out this. So here I have. It means that here I have P2 equals to P1 V1 T2 over what? V2 T1. Now you want to be careful here when you are making what P2 what the sorry formula here. Now, and the main reason why this substitute my value here is because I want to make some sorry formula at once. After getting on here, then I will not start imputing what my value. So after I solve this one here, make what P2 sorry formula, then I can now impute what my value. Hope you understand. So it means that P2 is equals to my P1 is what? 0.825. 0.825. Right? My V1 is what? 2.76 times 2.76 times T2 is what? 150 over my V2 is what? 1.38 1.38 times my T1 is what? Is 300. Now you can see that I did not include my units because we go up here, ATM cancel at ATM, KB cancel at KB. Do that. So when you solve it, so let's go at the second question. It says that the pressure of 100 cm of oxygen at 35 degrees centigrade is 750 millimeter of mercury. What will be the volume of the gas if the pressure is reduced to 100 millimeter of mercury without changing the temperature? It means that at constant, without changing the what temperature. It means that at constant what? At constant what temperature. Do you that? So let's look at what. So instead of, in the question here, the volume is what? 100 cm cube. Do you get cm cube is what is volume? So my V1 is what? 100 what cm cube. Do you get that? My temperature is what? Now let me just say my T1 is equal to what? 35 degrees centigrade. Of course, whenever you see temperature, you need to convert to what? Kelvin. And to convert to Kelvin, you need to add what? 273. Do you get that? So 335 plus 273 is equal to 308 Kelvin. Do you get that? 308. Now, let's say the pressure is what? So then my P1 is what? 750 millimeter what? Mercury. Let me just do the case here. Yeah. Now I say what will be the volume? So V2 is what you are looking for. I might be what is centimeter. What will be the volume of the gas if the pressure is reduced? So my pressure is reduced to what? 100 what millimeter what mercury. This is that. Without changing the what? Without changing what the temperature. So my T2 is what is the same. Idea is what is the same. Please, you need to understand this question here. That is why gas law is one topic that what gives students challenges. Understand the question very well. Do you get that? Now it means that we are not using what? We are not using temperature. Do you get that? So now my relationship is going to be pressure related to what? To what? Volume. That I'm going to use first one P1 V1 equals what? P2 V2. So what I'm now say using P1 V1 equals what? P2 V2. Do you understand? Now what am I looking for? I'm looking for V2. So if I should want to make V2 the sort of formula here, so it's going to be divided by P2. Do that. we are making what V2 what sorry formula. Do you get that? So V2 is equals to P1 V1 or what? P what 2. Just so now what am I going to do here? I want to what substitute my value. Now my P1 is what 750 millimeter what mercury times my V1 is 100 centimeter over. Now my P2 is what 100 what millimeter what mercury. Millimeter mercury cancel what millimeter mercury, right? 100 cancel out 100 here, right? What will be left is what 750 centimeter what cube. So the option here is what B. This is that. Let's look at the third question. Now let's look at question 3, and I would like to do question 3 yourself. Pause this video now, then try this one, then drop your answer. Just say question 3 option. I want you to solve it. Pause the video and try it. I'll wait for you. Pause the video, drop your answer at the comment section. I'll look at it. Okay, now let's look at it very well. Hope you have solved it. So now it's a 300 cm cube of a gas solution. 300 cm cube of a gas. So that is my V1 going to be 300 cm cube, right? The gas has a pressure. That is the pressure. My V1 is going to be what 800 what millimeter what mercury. Now 300 cm cube of a gas has a pressure for 800 millimeter mercury. Full stop. If the pressure is reduced, so the pressure then my P2 is going to be what 650 what millimeter what mercury, right? It's reduced. Find the volume. So my V2. So which one are we going to use? Is it Boyle's law, Charles law, or JAMB gas law? Now because I'm looking at volume and what volume and what pressure. I'm using what for here. So it's going to be P1 V1 equals to what P2 V2. Do that. I'm looking for what V2 here. So I should make V2 sort of formula, then divide this by what. Hope you understand. Now in the sense that now I want to what calculate V2. So I'll make V2 sort of formula by divided by what P2. Do you get that? So what am I going to do? I'm saying V2 equals to P1 V1 or what P2. Do you understand? So what I want to do here is what substitute what my values. P1 is what 800 millimeter what mercury times my V1 is what 300 centimeter what cube over. Here we have 650 what millimeter what mercury. Because that millimeter mercury cancel what millimeter what mercury, right? What we like about centimeter, which is the volume that we're looking for. So what you want to do here is so punch your calculator and get your answer. 800 times 300 divided by 650. 369.23 what centimeter what cube. See that? So yeah, what I got to do here? Yeah, the answer is what B. Hope you got the answer. Let's look at what next question. Look at what question 4. This one is an interesting question, so you want to pay close attention. If both the pressure and volume of a given mass of gas initially are doubled, what is the final temperature? Please follow me closely. Solution. Now remember, the initial pressure and volume are not given to us, so we assume a value. So what I'm going to do, we say let P1 equals to what P what ATM, and let V1 equals to what V what CM cube. Hope you understand. Now because the value was not given to us, let P1 equals to what P Let V1 equals to what? V centimeter cube. P ATM. Do that. Now the initial temperature is what? T1 equals to 100 is what? 0 degrees centigrade. Remember, I'm going to convert this temperature to what? To Kelvin by adding 273. It means that 0 plus 273 is equals to what? 273 what? Kelvin. Hope you understand. Now, is that initially, let me look at the question again. It's that if both the pressure and volume of a given mass of gas was initially at doubled, it means that my P2 is going to be 2 times D because it is doubled. It is what? Double. So it's going to be 2 PATM. Hope you understand. Then my V2 is going to be what? 2 what? 2 VCM cube. Do you get that? Now, then my T2 is going to be this. This is what I'm going to look for. Do you see that? So it means that I'm going to use general what? Gas equation. General what? Gas equation. If I should use what? My general gas equation, which was P1 V1 over T1 goes over P2 V2 over T2. So I'm going to do P1 V1 over T1 equals to P2 V2 over what? T2. What I want to do now is to look, make some sort of formula here by cross multiplying. Do that. When I cross multiply P1 V1 T2 equals to what? P2 V2 T1. Do that. If I should make P1 instead of formula, divide those by P1 V1 V1. So T2 is equal to what? P2 V2 T1 over what? P1 V1. Do you get that? What happened here? If I subtract my value, what is my P2? P2 is what? Is 2 PATM. 2 PATM. Are you following here? Times, you got my V2, my V2 is 2 VCM cube. 2 VCM cube. Do you see that? Times my T1. My T1 is 273 Kelvin. 273 what? Kelvin. Over my P1. My P1 is PATM. PATM times my V1 is what? VCM cube. So VCM cube. What happened here? PATM becomes what? PATM. VCM becomes VCM cube, right? What we left is what? 2 times 2 times 273. Do you get that? So if I should multiply it, so when I multiply, I don't space again here, so I'll wipe space out. Now, what happened here? So my T2, when I multiply it here, it's going to be 2 times 273 what? Kelvin. Do you see that? The answer is what? 1092 what? Kelvin. The answer is what? Is B. Do you see that? So let's solve another what question. Please, if this video is helpful, please comment at the comment section that this video is helpful and you're actually what? Getting value from this. And if you want to continue to make this kind of video here, please leave it at the comment section. That will tell me that you are actually what? Interested in this type of what? Video. So let's move to the fifth question. So let's look at what? Question 5. They said the volume of a given gas is VCM cube at P millimeter what? Mercury. Full stop. What is the new volume of gas, comma, if the pressure is reduced to half at what? If the pressure is reduced to half at constant what? Temperature. At constant temperature. So my V1 here is what? Is VCM what? Cube, right? And is what? P what? Millimeter what? Mercury. Just that. If the pressure is reduced to half, that means the answer what? If the pressure is reduced to half, so what is the new? What is the new pressure? So what is the new volume? So my V2 here, I don't know it. I don't know it here. Now, if the pressure is reduced to half, so my P2 is equal to what? Half of my what? P1, which is what? P millimeter what? Mercury. Hope you understand. These are P2 is half of this guy here, so that half times P millimeter mercury. We also see it as what P millimeter mercury over what 2. You get? So now we're going to do here. So here I say P1 V1 equals to P2 V2, right? Now make it G2 set formula here. V2 is equals to what P1 V1 what V2. So P2, right? So what I want to do here is to impute my value. My P1 is what? P millimeter what mercury. P millimeter what mercury times my V1 is what VCM what cube over. Look at that. My P2 is what P millimeter mercury divided by what 2. So it's going to be P millimeter mercury over what 2 here. Do you see that? So I want to what reduce this one here. If I should reduce this one here, remember this divide is also the same thing as everybody this one adds. So here we have, so my V2 here is equals to, here I have P millimeter what mercury times VCM cube. I will say what divide, right? Here we have P millimeter what mercury over what 2. Just that. Now I will change what to times now. If I change what to times, so we'll go up, so we'll come down, right? So we have P millimeter what mercury times VCM cube times 2 or what P what millimeter what mercury. So what happened here? This we cancel out this one here, right? So the answer is going to be VCM cube times 2 going to be 2 VCM cube. What is the answer? The answer is what is A. So move to what question 6. Let's look at what question 6. Okay, a given amount of gas occupies 10.0 dm cube at 4 atm and 273 watt Kelvin. The numbers of moles of the gas present is dashed. So here we have to use what ID gas equation. Yeah, because here we have what numbers of moles. We are going to use what the ID gas equation, which is going to be PV equals what nRT. Where P means what pressure, V what volume, T what temperature. Now R is a gas constant. Now it's supposed to be given in the question, which is what 0.0821 atm liter per mole per watt Kelvin. In case you want to understand the ID gas equation, I've done a separate video explaining the ID gas equation, so you can check it at the comment section. You see that video. And secondly, I've also done a complete video on gas laws. I also leave it at the comment section. Do you get that? So this is called R means what the gas constant. So in the question here, they have given us what the volume. They are giving us the volume. Volume V equals to what 10.0 dm cube, right? Now my pressure is what P is what 4 atm. Do you get that? Then my temperature is what 273 watt Kelvin. Now I must convert this one to what to Kelvin by adding what 273. So it's going to be 273 plus 273. What is the answer? 273 plus 273. Here we have 546 watt Kelvin. It's very important to convert to what. It's very important to what you convert to what Kelvin here. Now the unit here will remain in dm cube atm. Like what I say, I've done a complete video on ID gas equation, so you can check the link at the description. Now the next thing I want to do here is to find out what my gas constant, which is 0.0821 atm liter per mole per watt Kelvin. So now what am I looking for? I'm looking for what mole. This n means what numbers of what mole. So because I'm looking for mole, PV equals to what nRT. Now if I should what make n instead of formula here, my n is going to be what PV about what T, right? So what I want to do here, I will include what insert my value now. My pressure is what 4. So it will be 4 times My V is what? 10 over my arrow is what? 0.0821. 0.0821 times my T is what? 546. Do you see that? So what you want to do here is what? Use your calculator to punch your calculator. Use your calculator to punch your answer, and equal to 0.89. 0.8 what? 9. Now the unit must be what? In mole. Do you get? So this is the answer. The answer is what? Is. So this is where I want to end our video today. Thanks for staying to the end of this video. If you have any question, leave it at the comment section. If you have not subscribed, please make sure you subscribe. Next video is coming up on organic chemistry, JAMB question here. Organic what? Chemistry JAMB question. JAMB revision question in what? Organic chemistry. This way I want to do a lot of video. I'm also going to do the part 2 of this video where I want to do the gas law of diffusion and other topic related to what? To this gas law. So you don't want to miss out. You want to subscribe to the channel here and hit the notification bell so that you can be notified whenever a new video is upload. Please, if this video is helpful, please give it a like, give it a thumbs up, and subscribe. Share with your friends. Also, look for this type of content. Do that. See you in the next video.